Good day to doctor. My name is Khor Jun Hao. My matrix number is 17207134. This is the video for mini case study for WIC 3004 computer penetrations. The title of my paper is The Defense Against ARP Spoofing Attacks Using Semi-Static ARP Cache Table. So this paper is published on 2018 and in the IEEE. So I will talk about the overview of the articles. So securing the user data that passes through the internet is very important challenge until today. One of the threats is the attack on the data links layer such as ARP spoofing. Those attacks exploit the vulnerability of the ARP protocol. One of the most traditional methods but effective solutions to mitigate this type of attack is adding MAC and IP address to the static ARP cache table manually. However, this solution is a very troublesome and laborious job, and not all the network administrators willing to do it. So this research proposed a method to improve the static ARP cache table solutions. Our purpose are removing the laborious process of adding the static ARP cache table manually and adding the ARP validation functions to manage the static ARP cache table automatically. So this proposed method is simple and compatible with standard ARP protocol. It does not require any modifications of the standard ARP protocol or replacing the old device. So what is ARP spoofing? Since ARP spoofing is redirect the MAC address of users to attacker ones, I will say about the IP address and MAC address of the device. So all devices that connected to the internet has two types of address. One is IP address and one is MAC address. The IP address is a logical address of the device. IP address used to identify the locations of the device that connected to the internet. It will change dynamically when connected to internet at different locations. So the MAC address is physical address that's stored inside the network interface card. The MAC address used to identify the location of the device in a local area network. The MAC address is unique and unchangeable. So how the data is sent? When sending a frame of data in local area network, the sender must know the MAC address of the receiver. The sender uses the ARP protocol to translate the IP destinations inside the frames to a MAC address of the destination device. ARP protocol comprises of two types of messages. They are ARP request and also the ARP reply. ARP request specifies the IP address of the target host MAC address. ARP reply specifies the MAC address associated with that IP address. So for example, when incoming friends arrive at the gateway tries to find the MAC address. So it will associate with the destination IP using its own ARP cache table. So if it's failed, then the gateway will broadcast a ARP request that containing the IP address of the destination device to all devices in the subnet. Like this. Then the device which recognizes the IP as its own will send an ARP reply, and other devices simply ignore this ARP request. So this receiver is matched with the IP address 104. So it will tell the MAC address and ARP reply, and it's unicast to the sender. So the other will just ignore because it does not know the IP address. So how attacker has chance to attack? So ARP accept a reply even without issue any request. So in addition, there are no authentication methods in standard ARP protocol. There is no way to verify the eligibility of the sender. This stateless behavior of the process is the vulnerability of the ARP protocol. The attacker attacker can easily manipulate the ARP packet, tricking the gateway of other devices to perform an ARP spoofing or ARP poisoning. So the type of the ARP spoofings. The first one is the ARP request spoofing. So the ARP cache table poisoning using an ARP request. Attacker sends the ARP request packets to the victims. This ARP request packet contains a spoof data to trick the victims. The victim believed that the sender of the ARP request packets was the host 10.0.0.1. Therefore, the victims cache the information from the ARP request packets into its own ARP cache table. So whenever the host 10.0.0.2 send data to the host 10.0.0.1, the data goes to the device with the FFF MAC address. So in this case, it is the MAC address of the unknown device. So this victim cannot connect to the internet or other network because the packets that he sends never reach the gateway. So the next one is a man-in-the-middle attack. So when attacker sends spoof ARP request to the gateway and the victims, so the poison reroutes all the traffic between the gateway and the victims to the attackers. So the attacker then acts as a relay between them. So you can see that you go send the request and tell the gateway that the 10.0.0.2 is at the CCC, which is itself. Then he also send a spoof ARP request to this client and tell that the gateway is also at CCCC MAC address. So all the information they sent will first go to the attacker first, and then the attacker can get the message. So this victim usually does not aware of this attack because there is no disruption in the network connections. So the attacker is to eavesdrop the communications between the victims and the gateway. So how to mitigate ARP spoofing with the semi-static ARP cache table? Why we use semi-static ARP cache table? This is because the original way is very troublesome because we need to add the IP and the MAC address to the static ARP cache table. So with the semi-static ARP cache table, we can automate the process and add the ARP validation functions to manage the ARP cache table automatically. The main purpose of these methods are to remove the rebellious process of adding the static ARP cache table manually and adding the ARP validation functions to manage the static ARP cable automatically. So it is implemented in the application layer of the internet layer stacks. So it does not require any modifications of the standard ARP protocol. So what is a semi-static ARP cache table? It consists of three major procedures. The first one is listing the IP and the MAC address that already cached in the ARP cache table. The second one is validating this IP and the MAC address. The last procedure is set valid IP and MAC address as a static record in the ARP cache table. Operating system cache the IP and MAC address inside the ARP cache table to minimize the broadcast message of ARP protocol, so it can reduce the chance to get vulnerable. So how it works? The first step is creating an empty whitelist. Then it will go to the first IP and the MAC address in the ARP cache table. Then it will check every record in the cache table by sending the ARP request packet. So we can utilize by using the ARP tools to do this job. ARP ring is a tool that sends the ARP request packets to an IP address. So the first reply of the ARP command will be validate. Okay, get reply, then we validate the MAC address. So if no, it will remove the IP and the MAC address from the cache table and the whitelist. So it will continue to here. So if it is last record, then we will stop the process. If it not, we go to the next IP and also the next MAC address. So this will redirect back into here and keep on doing. So how to validate the MAC address? This is the detailed process. So at first, the system will check whether the IP which already being checked using the ARP. So it's also already in the whitelist. If the IP is not in the whitelist, then the system save the IP and the MAC address into the whitelist and set it as the static record in a ARP cache table. So if the IP is already in the whitelist, then the system will check whether the record is expired or not. If it is expired, then a new MAC address will be replace the old MAC address in the whitelist and the ARP cache table. So if an IP is in the whitelist and it not expired, but the MAC address value does not identical, then it might be an ARP spoof attack. The system will replace the MAC address in the ARP cache table and set it as the static record here. So for the implementations, they shows in the paper. The first, the setup is in test by the virtual environment using the virtual box. The virtual box consists of 4 virtual machines, a router, and also 2 clients, and also 1 attacker. All of them are using the Linux Ubuntu servers as the operating system. So in the virtual box, internal network is used to connect all the devices connected, and then the network topology of the virtual environment is shown in this picture. All the IP address in the topology is using the static IP address. So to evaluate the effectiveness of the semi-static ARP cache table, so the program that contains the semi-static ARP cache table is only set up in client 1 and also router. Then the client 2 does not set up to show the difference. Then we will launch an ARP spoofing attack in the attacker side node by using the SCAPI. SCAPI is a tool for manipulating the network packets. It can fork or decode packets and send them on the wire, capture them and match the request and reply. SCAPI is used to manipulate the IP address and MAC address of the source and the destination ARP header in several scenarios. So the result of the implementations. So in the experiment, the ARP spoofing attack launched first. Then this is one of the scenario. So as expected, the ARP cache table in some nodes are poisoned with the fake MAC address. The poisoned ARP cache table, when we attack using in the scenario 4, which attacker sent a broadcast ARP reply to the entire subnet. So the client 1, you can see client 1 and client 2 is affected by this attack. So then we run the mitigation program on the client 1. The program capable to recover the poisoned ARP cache table and defense against the further attack. So you can see the MAC address is changed from the fake one back to the real one. So but in client 2 it does not change because it does not have the programs inside. So in other scenario, we can see that from this result, you can see that for the first one, we will send a spoof broadcast ARP request. So 2 clients will be affected. So after the mitigations, you can see that client 1 is recovered. So for second scenario, it will send only unicast to client 1. So client 1 is affected, then recover. So the next one is to client 2. Client 2 is affected but does not have the programs, so it does not recover. So the fourth one is the spoof broadcast ARP reply to tell that it's at 11:11:11. So also 2 of the client is spoof, then only client 1 is recovered. For the fifth one, we use the unicast ARP reply to the client 1. So client 1 is spoof and also recover, but for the scenario 6, the client 2 is spoof and also not recover. So the number 7 is the MITM attacks to the routers and also client 1. So the router is spoof, client 1 also spoof, then they both of them recover. So the last MITM attacks is to all using the unicast. So the router client 1 and client 2 is all spoof, but only a router and client which have the programs are recovered. So from the result we can see that the percentage of recovery is almost 100, so it's very effective against the ARP spoofing attack. So in my conclusions, after reading this research paper, I think that the semi-static ARP cache table is easy to implement in every host. The implementation is easy to apply by using the Python programming and apply to the layer of the internet layer stack. We do not need to modify the current standard ARP protocol at all. Overall, I think that the research paper is very easy to be understood. So from introducing the ARP spoofing attack to the implementation of the semi-static ARP cache table, all written in very detail and explained in a good order. So in my opinion, I think that we can develop a communication protocol between the hosts so that when we found spoofing on the other host, like what we see just now, for example the client 2, we are able to give warning to the client 2 when they are in the ARP spoofing attack inside the network. That's all from me. Thank you.